Hi everyone, can someone please confirm if I am audible on Zoom? Okay, thanks for confirming. So welcome to the second orientation for the F110 Sim Racing League organized at IROS 2024. Uh, Glad that you all have joined. Hopefully others will join soon. So we'll get started. Uh, First, we'll basically cover the same agenda that we kind of covered in the first orientation. If people who are joining are new, couldn't attend the first orientation or for other reasons, we'll just go over it quickly this time instead of delving too much. And then we'll have other aspects that are specific to orientation too. So again, I'd like to acknowledge all the people that you see here on the slide and even beyond this who have helped organize this event. And while Chinmay and I will mostly be doing the talking today, it have been possible uh, besides these people to have this event successfully conducted. So a huge shout out and thank to them that we are all here. Again, to get in touch with us or the competition in general, we'll be posting the updates mostly on the competition website. We also have a dedicated Slack workspace to decide and discuss about different aspects of the competition. If there are some technically core doubts or kind of suggestions, then you can also have discussions in the GitHub repository. And lastly, if there is something private that you want to discuss with the organizers, possibly things that cannot be discussed or published in public domains, such as the ones listed before, you can contact either Chinmay or me directly via our email. But that is sort of the last resort because there are spam filters and all the other kinds of problems that your emails may not come through to us. So ideally, we ask that all of you mostly communicate through the aforementioned channels that are publicly open. So we'll first cover the competition overview, followed by rules and regulations and technical aspects of the competition framework. And then we have a few live demos planned again this time for you guys. And then lastly, we'll open floor to the questions. So to briefly go over the competition overview, the 21st F110 Autonomous Grand Prix is basically the uh, father of this competition, which hosts two competition leagues. One is the physical racing league that will happen in person at IROS 2024. And we have already 20 registered teams for that. And this will, as the name suggests, comprise physical F110 race cars and the racetrack at the IROS event. And the mode of competition there would be a time trial race for qualification, followed by head-to-head autonomous racing. But what we are mostly here talking today is about the Sim Racing League, which is the second sub-competition under the 21st F110th Autonomous Grand Prix, which comprises of virtual competition, which will be held ahead of IROS, which basically means approximately a week ahead of IROS 2024. Uh, and this will, as the name suggests, have virtual F110 race cars within a virtual racetrack in a simulated environment. And since this is the first ever deployment of the F110 Sim Racing League, we are keeping things simple for the first iteration with just a time attack racing format. So a little bit more about the Sim Racing League now. Uh, since most of you are here, I'm assuming you have already registered for the Sim Racing League. So that's done. And the orientation one, which was held, I guess, 2 weeks before, has also concluded. And we had some good discussions back then, and even after the first orientation. So today we are at the second orientation where we'll be checking your progress and helping you with any technical difficulties. Going ahead this weekend, upcoming weekend, we have the qualification round where you would be submitting your containers for the first time. And the idea there is to now be able to complete 10 laps around the racetrack. And this is the same track that was given to you for, testing and developing all these days. So the idea is, yeah, you have to complete 10 laps without colliding too many times. And well, after that, we have a few more events planned for the same competition. We'll be releasing the competition track approximately 1 week ahead or a few days ahead of the final race. Then there will be, of course, the final race where we'll collect the containerized algorithms the second time, this time for the competition racetrack. And then we'll be running the same performance metrics and analyzing each team for their performance, and then ranking you based on your time to completion in the actual final race. And the standings as well as the data for all the teams will be released shortly after the final race concludes. So this is the overall competition timeline that we have been following. Today we are at this event, that is the second online orientation. As I said, the upcoming weekend you have the qualification round. On October 4th, we have tentatively planned to release the competition track, which is a 1 day ahead of the final race. This may change depending on how teams do in qualification, as well as how many challenges are faced by the teams. So we may decide to release the competition track a few more days earlier so that you get sufficient time to develop and debug your algorithms. But yeah, we'll be posting about that on the Slack channel as well as on other forums, and of course the competition website itself. So do keep checking the respective notifications for and the competition website itself for any changes in the release date for the competition track. But as of now, it still stands at 4th of October. And after the final race on the weekend of 5th and 6th October, we are tentatively planning to release the results on the 7th. But again, this may be pushed by a day or two, depending, because we have a lot of teams running the competition framework for all the teams, and then making sure that there are no glitches or errors in judging the performance of each team. After doing all of that, we may take a few more days, but we'll do it as soon as possible after the final race concludes. So once again, about the competition resources, one thing that we wanted to highlight, and there have been a couple of questions being asked either on Slack or directly to us, is about the different resources available for the competition. So what we wanted to make sure that everyone today understands and is cleared out is that all the resources that you need to use for the competition are linked on the competition website in the resources section, and this is just a snapshot of the same. Autodrive ecosystem is generically a much larger thing than just this competition, and as a result, we have a lot of other resources, including F1TENTH simulations and other APIs and example setup, which are not directly linked to the competition. So for the competition, we do have specific API, we do have a specific simulator, and we ask that you use the links given in the resources section of the competition to download these. They may be the competition documents itself, or more importantly, the containers and the local resources for the simulator as well as the dev kit. So please use these links rather than generically going on or Googling about Autodrive GitHub or Autodrive Docker Hub or other things like that. At the same time, the online orientation resources for the last orientation have already been released on the competition website, and you can use these links to download them. And we will be doing the same for the second orientation as well. So just wanted to bring that to your attention in case you have missed it. So now let's talk about some rules and regulations for the competition. Again, just reiterating these from the last orientation itself. So one of the things that we kind of again want to highlight is that please be aware of what you are submitting to us. Make sure that you have checked all your submissions for both technically that they are technically sound and working before submitting, and secondly, and more importantly, that they are plagiarism free and abide by the code of conduct of the competition. So generally, the eligibility criteria for this competition was that it was open to everyone across the world, and its registration as of this iteration was free of cost. And the structure would be to now, from our side as organizers, we would be providing each team with a standardized simulation and API in a containerized format. And you as teams would be now developing your perception planning and control algorithms to interface in real time with the simulator and make your F1TENTH digital twin run autonomously within the virtual racetrack. So we have two phases in this competition. One is the qualification race, which is in this case happening the upcoming weekend, and the second one is the time attack race. So the overall format of the competition is going to be a time attack racing format where each team will race independently against the clock, but on the same racetrack, so that it's fair and even for all the teams. There will be a total of 12 laps. where you start with a warm-up lap. As I said, you can use this lap to now, for example, make your localization estimates converge within the first lap. And what I'm saying by that is that first lap, which is the warm-up lap, the collisions or the time for that will not be measured or considered. What is once you finish the first lap, then is when you start in the 10 race laps, wherein the time for completion for each of the laps, as well as the collisions that you are incurring in each of the laps, will be taken into account uh, to determine your performance. And finally, you have one more lap at the end, which is the 12th lap for cooling down. You can use this lap any way you want. You can just decide to stop after the 10 laps, or you can decide to, log some data after the 10 laps, or you can uh, play cool at acrobatic stunts in the final 12th lap. Do whatever you want in the first and the last laps. That's the first and the 12th lap. But what you need to be very careful about are the 10 laps in the middle. So we'll, as from the evaluation standpoint, we'll be taking the total race time into account as the final and absolute metric for deciding your rank on the table. However, in case of a tie or in special cases, we may also consider the best lap time or other metrics depending on the situation. Talking about collisions, you will incur a penalty of compounded 10 seconds for each collision. And what this means is first collision will incur 10 seconds, the second one will incur 20 seconds, and that is now considering the first and the second 30 seconds up till now. The third collision will incur 30 seconds of penalty, so total of 60 seconds, and so on. And the maximum permissible number of collisions for the entire 10 race laps is currently set to be 5, beyond which, like if you collide more than 5 times within the 10 race laps, your team will be automatically disqualified from the competition. So the idea here is not just to race wildly, but to race safely. And that's why we are setting a higher limit of 5 collisions, beyond which the teams will be disqualified. Finally, the lap times, as I said, during the warm up and cool down laps will not be considered, and same applies for the collisions as well. Those two metrics will be only considered for the 10 race laps in the middle. So talking a little bit about submission process, and this is where you guys would now have to start thinking seriously, is that you will have to containerize your algorithms. That is the dev kit portion of it. You don't need to worry about the simulator containerization. We will be running it from our side. One important thing here is, again, as highlighted in the first orientation, your containers should be self-sufficient in terms of deployments. And what we mean by that is based on the entry points that you have defined for your containers, your algorithm should automatically spin up, try to connect with the simulator, and then start running in autonomous mode. So all we will be doing from our side as organizers is running the simulator container and running your container, and they should start talking to each other. We'll make sure that the networking is working perfectly, but your algorithm should basically bring themselves up by themselves, and then start running in the loop until the 12 laps or at least the first 11 laps are completed. So in terms of the next steps, you will have to, again, as I said, containerize your algorithms, make sure that they are self-sufficient in terms of running, then push them to Docker Hub and share a link with us as we will release the submission form soon. There are a few caveats to this as we talk about the submission privacy. So you can host your source code in a private GitHub repository. GitHub allows even personal accounts to now host private repositories, so that shouldn't be a big problem. But for Docker Hub, you have one private repository per free account. So if you already have an account that uses a free repository, you can kind of create a new one just for this competition or for F1TENTH Sim Racing League in general, and then have that private repository for yourselves. But either you will have to give us access to the same repository that you are hosting privately, by which we can download it and run it from our side, or you will have to, for a limited period of time, make it public, but make sure that you don't post the link or have obvious names given to the repositories that others can, potentially Google or find your repository from Docker Hub search. That's left up to you. But of course, after the competition, we certainly encourage all the teams to publish their source code, Docker images, and other kind of race data or logs, reports, even potential publication papers that you might have coming out of this competition publicly, so that others in the community can benefit and the standards for the competition are uh, leveraged or increased each iteration. So that's just a suggestion. So let's now talk about different technical aspects. So I'll ask Chinmay to jump in here.
Thank you very much, Tanmay. Uh, so as Tanmay mentioned, let us now quickly go over some of the technical aspects again. Most of this is just a reiteration from the previous orientation for people who might have missed the earlier orientation. And again, if in case in general miss any orientation sessions, the recordings are made available on the competition website. So this is just a glimpse of what you will be expecting in this competition in general. So much like the physical F110 racing competitions, we have a digital replica of the same, both in terms of the racetrack as well as the race cars. And in this video particularly, for example, what you see currently in terms of multi-agent racing and things like that, those are some of the future plans or future deployment aspects of this sim racing competition. But certainly most of the other aspects, for example, the digital twin simulation and the communication APIs and development frameworks in terms of the ROS2 packages, etc., is still a part of this competition. So feel free to explore these resources. These have again been released publicly. So if you have the curiosity or interest, you can feel free to explore them. So before we talk about the technical guide, I just got a small information to share with you all. With respect to the competition framework itself, it's not strictly necessarily to be used for the competition purpose only. You can, if you are in academia, for example, if you are a master's or a PhD student or even an undergraduate student who is pursuing research in this similar or a related field, you can feel free to explore or utilize these competition resources for conducting your own research. And that's very well encouraged and, something that you can pretty much do. So in terms of the technical guide, again, we have highlighted a few important things here, which are again, by the way, listed in the technical guide at different places. So one of the most important things here is the kind of computational specifications that we will be running the entire framework from our side on. And so that is one thing that's important. The other thing is that we do expect some technical expertise in terms of working with the framework. Although we have tried to make it as user friendly as possible, the frameworks themselves or the ROS2 APIs or the things like working in a Linux environment, etc., or working with containers and Docker, for example, are some of the things that we do expect the teams or at least a subset of the team members know or are familiar with. But considering the amount of interaction we have had with the different teams, I don't see that as a problem, especially for the IROS 24 competition deployment. So that's not a very huge issue. So maybe we can start talking about the simulator itself. Again, just to reiterate, the technical guide covers things like the system requirements, the user interface elements in terms of both the menu panel that you see on the left-hand side as well as the heads-up display on the right-hand side, the vehicle characteristics in terms of the rigid body transforms, characterizing the different component subsystems of the vehicle, then the vehicle dynamics aspects, the sensor physics aspects, as well as in terms of the environment, you have again the transforms indicating the different prominent parts of the environment, such as the global frame of reference, for example. You have the size and structure and the layout of the track that would be used for the final competition track as well. So although the shape and profile might be different, that is in terms of the design and features, you can certainly expect some things like, for example, the dimensions of the air ducts, which are again a standard uh, size for the physical F110 competitions as well. So those kinds of things will still remain intact, but we might introduce some variability just to ensure that your algorithms are robust enough to work in different and diverse environments, as opposed to being very, very finely tuned for a very specific racetrack. In terms of AutoDrive Dev Kit, again, in the technical guide, we have mentioned the system requirements, the package structure, as well as the different data streams that are available. So here, and for the simulator as well, the system requirements that we have mentioned, one thing we would like to highlight is there are certain aspects. We have tested the framework on different configurations of laptops and desktop PCs in the lab that we work in, but and we have tried to create a generic enough system requirement documentation on the website. But there are a few things and that heavily depend on the hardware as well as software configuration as well as the operating systems and things like that. We will talk about that in the later part of this orientation, but there are a few things that are beyond our control, and really it is not very much possible for us to cater the or optimize the simulator or dev kit for a very specific system configuration. Uh, in terms of the package structure, we have the package that we have for the ROS2 API of the simulator itself. And then we ask all the teams to create their own package or packages in the same workspace without disturbing the package that we have created. So you might have a temptation of possibly, start to create your own scripts or launch files right within the AutoDrive F1TENTH package. But that is something that we do not encourage. We want each team to create their own package and then start from there. This way, it will be also easier for you to maintain your code base and potentially release it at a future point in time. In terms of data streams, we have listed all the topics, the type of interaction in terms of how it is being set up in terms of the communication from the simulator and the dev kit, the message structure, as well as the access to those topics. So we had a few questions asked after orientation 1 or even before that in terms of the access. So all the topics that have restricted access can be strictly only used for debugging purposes. You cannot use any subscribers or any kind of input data from those topics to run your algorithms. Especially, you can, for example, think of it even to the like the maximum extent. What you can do is you can potentially use them for debugging or optimizing your algorithms. But during the deployment or the runtime of your algorithms, they should not be subscribing to or having access to these topics. If that makes it more clear. So as Tanmay was highlighting earlier, and to pictorically depict it, we have this image on the competition website as well as the slide that you see currently. From our side, what we will be doing is spinning up the simulator container image as well as the dev kit container image that you provide or submit. In the dev kit container image, we do expect the dev kit ROS2 package, that is AutoDrive F1TENTH package, to stay intact as it is and as it was given to you. And you will basically have a job or the role of creating your own ROS2 package or packages here that can communicate with the different topics or the message streams that have been exposed via the ROS2 package that we have. And this we will be running on a PC in our lab with the specifications mentioned on the website again. So you don't have to worry too much about those aspects. But one thing that we had been previously saying is if it is very well understood if you are using Docker for the first time, ROS2 for the first time, or AutoType Simulator for the first time, you might be overwhelmed by some of these things, especially working with all of these things now in containers. So one thing that we had advised previously is to test everything locally and then go ahead and containerize and submit. But considering that it's about a week now uh, from the submission phase uh, for the qualifying round of the competition, we expect at least that most of the teams have figured out the containerization aspect and you don't have any particular issues with that, and that you will be in a very good shape to submit your containers once the submission forms. So now let us move to a live demo. There are some things that we would like to highlight here. One is the aspect of distributed computing. So in distributed computing, what we mean by that exactly is you can run the simulator application on one PC, and then the dev kit can be run on another one. This applies to both local as well as containerized implementations. So one of the key requirements here is that both of these computers should be connected to a common network so that they are discoverable and can communicate with each other. And this would work very well for the purpose of this competition or in general as well, for exploring the competition framework or using it for research or academic purposes, etc. What this will do or what benefit this possesses is offers is uh, you can now offload the simulation workload on a different PC and the dev kit workload on a different PC, so that you don't have to worry about the latency that this might cause, especially when you consider the computational framework itself. There are different processes, and the event scheduler of your operating system now tries to schedule them according to its own preference. This varies with different versions of Linux. This might be totally different on machines running Mac OS, for example, or Windows OS. So it varies greatly there. It also depends on the software configuration. For example, if you are running this via Docker or you are running it locally, if you are running it via Docker, then do you have a Docker engine that's natively supported on Linux only systems, or are you trying to run it via Docker desktop, which is now much widely supported? Because Docker desktop, what it will do is it will create its own virtual machines by allocating a subset of your host operating system resources, so that the host itself does not crash and things like that. So you can try to isolate these processes and potentially gain performance out of this. If we particularly see or observe any team's container facing a significant amount of issue, we will try to do this in our testing framework itself, so that you don't have any issues when we deploy our code, and that does not affect the performance of the team's code. The other aspect is being able to run the simulator as well as the dev kit in headless mode. So we do offer a default GUI mode for the simulator as well as the dev kit. And you might have already observed, if you would have explored, that the current version of dev kit that was released, it by default in the entry point launches the launch file that basically runs the AutoDrive F1TENTH node to communicate with the simulator, as well as an RV session to basically a pre-configured RV session to visualize all the important information in real time. But what is also possible is to now run the dev kit or the simulator in a headless mode. And I'll probably, just after explaining this, demonstrate that to you so that you have a clearer idea. By the way, we have also just released updated versions of the dev kit as well as simulator that do support this feature. The earlier ones will not support, especially the simulator version will not support the uh, headless mode. But now we have uh, a new modification introduced that enables you to have an auto drive command line interface to interact with the simulator, and then you can basically launch the simulator in headless mode and then configure the IP address and port number from command line interface instead of using the GUI. And what that does is basically offloads your rendering, and you can basically potentially gain better performance. From our side, during testing on different PCs with different configurations, we did not see much of a problem, although we have observed some of the teams reporting some issues. We have been consistently getting good frame rate, and by good we mean upwards of 60 hertz. Uh, and then in terms of the topics that are being published, the frame rates, the topic rates are also well above 15 to 20 hertz. So that's one thing. The other thing is in some of the uh, discussions with teams, we observed that uh, they are not entirely sure about the simulation framework itself. So One thing that we would like to highlight here again is that we are simulating the vehicle as well as the environment exactly or very closely resembling the real world counterpart. So we have characterized all the sensors, the dynamics, and etc. All the other components of the vehicle with respect to a physical F110 vehicle that we have in our lab. So all the sensor characteristics as well as the streaming rates, etc., have been configured that way. But what comes by that, what we mean is basically, for example, if you consider the LiDAR scanning rate of 40 hertz, which is the upper limit, the simulation is considering that rate. The encoder uh, rates are the similar. Then you have the camera, the sensor size, the aspect ratio of the image, and all those kinds of things uh, being simulated exactly the way they happen in the real world. The only thing is that depending on the compute you are running or trying to run the simulator or the dev kit or both, uh, these numbers might vary a little bit, since, as I mentioned, there are issues pertaining to how your hardware and software is set up, how your GPU is communicating with your CPU, and how much uh, how many number of calls does it support, etc. But it has been taken care of that the simulation resembles the real world as close as possible. Uh, Even in terms of the vehicle dynamics characteristics, such as the lateral and longitudinal slip of the vehicle. So you might observe that the encoder ticks are uh, ramping up much faster than expected. That is because the vehicle is not moving kinematically. It is behaving realistically in terms of dynamics, and the longitudinal slip that is created on either of the wheels is now affecting the motion differently, and the encoder takes differently, if that makes sense. So with that being said, let us now move to the demo piece. So I hope my screen is visible. And in terms of the resources again, uh, the official Docker Hub repositories for simulator and DevKit have been recently updated. So if I just go to tags, you will see that the changes for both IROS and CDC have been recently pushed. So you should be able to replicate these things. Again, for people who have been comfortable with the earlier framework, this does not change anything radically. All it does is gives you an additional capability of running things in headless mode, if that is something that can benefit you in terms of the computational performance. So maybe what I can do now is just show you this in action. So one small thing while running, and we have updated the documentation already. When you are trying to run the newer Docker containers, you will need to provide a small argument, that is this entry point bash argument. And what that will do is essentially open a bash session. Earlier in the entry point, what we used to do is launch the simulator application or the devkit launch file directly. We do have those in the entry point for your reference still. You can refer to them at any point in time you want, but they are just commented out so that you get a flexibility in terms of how you want to run things. So after running the simulator container, you will end up in a location where the simulator executable exists. And this is where you can launch it either in the GUI mode or headless mode. I'll just demonstrate that in a moment. So for the devkit container as well, here, what you can do is just by adding these new arguments in the Docker run command, you can launch the devkit as well. So again, in a very similar way, you will end up in a location where all your necessary things, for example, the workspace as well as the core ROS to files have been sourced, so that you don't have to worry about that while deploying and testing. So let us first look at this option where we want to run things in a GUI mode. So for simulator, I can just paste the command and it will launch the simulator application. Much in the same way for the dev kit, we can first try the explore the GUI mode. So as you can expect and as you might be already aware, this is how the GUI based option works. For example, I can probably teleoperate the vehicle and demonstrate the GUI mode to its extent. Now, in order to kill, I can simply kill these instances and exit the container. This is not necessarily ideally, so the command will stay the same for running these things now headlessly. So for headless, we have this option where, for example, for the simulator, you can pass on the arguments that I was just talking about. So these arguments are now uh, command line arguments for auto drive simulator. So is in addition to just launching the executable, you are passing on these arguments to ensure that the simulator works in headless mode, and then you can pass on the arguments for the IP address and port number that is run of the machine that is running the dev kit. By default, in the documentation, we have set up the loopback IP and the default port number of 4567. Hopefully this port is not occupied. If it is, we have already shared the process of how you might go around, configuring and working with a different port number, but that's a very infrequent issue. So let me just copy this command and execute it in the simulator container. What you should expect to see is some print statements or some debug information populated in the terminal window without any simulator GUI window popping up. For the dev kit, we have this headless launch file that will take care of the things for you. And so you can expect to see the connected message displayed in the dev kit container, which essentially means that the connection between the simulator and dev kit has now been established. And we can go ahead and start a bash session in the dev kit container. And we can, for example, out the different topics that are available. And this way you can basically now, for example, let's see if I want to verify that the communication is working, I can probably kind of echo a few different topics, and that way I know that the communication is working, and now whatever algorithms you run will work exactly in a similar manner, but just you won't be visualizing. You can also do mix and match of these modes. For example, you can run the simulator in headless mode, but you might want to, for example, run the dev kit in a GUI mode. That is also possible. But one thing that we would like to highlight here is that headless mode of simulator will disable the rendering processes, and as a result of which the camera frame would not be available anymore. So for those who are working with camera-based perception for doing autonomous racing, we would highly encourage or advise you to utilize the simulator in a GUI mode. You can choose to use the dev kit with or without the GUI. And for potentially optimizing your performance, if you are working with low spec computers, or if your network is not supporting high bandwidth, what you can try is the distributed computing mode, where you can run the simulator and the dev kit on different machines. For simulator as well as dev kit, you do not necessarily need machines of similar configuration. They can be of varying configurations. They can use potentially different operating systems and things like that. But the only thing that you need to make sure is that both of them are connected on the same networks and can communicate with each other. You can try to use the ping command, for example. You can use ping and followed by the IP address of the other machine to see if they can communicate with each other. So that basically concludes the live demo portion, and we can go back to the presentation mode.
Thanks, Chinmay. So a few things again to highlight during especially what was covered new for the second orientation today. One is that both of these things were now mostly related to having different types of compute platforms, limitations in terms of computational power, or other configuration issues such as the graphics drivers or the operating system scheduling, etc. The first thing that we discussed was about distributed computing mode, where you can run the simulator and the dev kit on two different machines, probably a higher end machine for the simulator and a lower end machine for the dev kit, because you can even choose to run the dev kit on a physical F110th car's onboard computer. That's any Jetson family as well, since your algorithm should ideally also work on that. And that way you have a hardware in the loop implementation with the simulator. But for the simulator, you would typically need a little bit higher end PC than what you would need for a dev kit. And the system requirements are already in place on the competition website for this. So this way you can get rid of any issues that basically overburden your single compute with both the simulator and the dev kit running. Again, as Chinmay highlighted, one requirement in this case is that both of these machines should now be on a common network. One thing I wanted to highlight here is that this common network can be an intranet or basically a router that just routes both of the connections from both of the PC. It can be an Ethernet switch, for example, and you don't necessarily need to have an internet access for this. All you need to have is a gateway for both the PCs to communicate within a single channel. The second thing that was covered was the GUI versus headless mode. Here, typically, this will help people who are having issues due to low-end graphics drivers or the graphics cards in general. So what this will help is basically disable the rendering pipeline entirely for the simulator and run only the physics engine in the background. Uh, a small caveat to that is, as Chinmay explained, the camera frames will no longer be available for you to now run your autonomy algorithms on. So if you are using camera frames, then you will anyway have to use the simulator in the GUI mode. And that for that, like if you are facing issues with latency or other kinds, we would refer you to the distributed computing mode to now make sure that your workloads are balanced across different compute nodes. But GUI mode will typically help people who are not using camera but are still facing issues due to GPU limitations, or more importantly, the driver configuration for running things in Docker, communicating with the GPU driver on the host system, the GPU driver now communicating with the CPU to now get all the render feeds from the simulator and put them on the GPU, and then the GPU actually computing and rendering them and forwarding them to your display. Where one of the things that was discussed on the Slack channel was the display frame rate. And if you are, for example, having a graphics driver that's basically throttling your GPU output or throughput based on your display drivers, then yes, you will have limitations in those aspects because they will be naturally throttled and your simulator will basically start performing at the same rate as your display is asking instead of taking or leveraging the full power of your GPU. So if those are the kinds of issues that you are running into or you don't know how to configure them, then you can certainly use the simulator in headless mode. But you also have to note that even in headless mode, you will still be limited by your CPU performance. So if you are using a really old laptop, which is basically not or below par than what we have in the basic or baseline system requirements, then you will still probably face issues. Although we have tried to make sure that even like 4 to 5 year old PCs in our lab can handle this simulator both in GUI mode and headless mode. Of course, we cannot guarantee that you use similar configurations or more importantly, your software configuration for the drivers or other stuff on your operating system is not exactly the same as ours. So that's why we have given you these options now to make sure that you are able to run things in much close to the real time performance as you would want. So with that, we have completed most of the stuff that we wanted to put out there. And as last time, you can use any of these links or resources within the presentation to revisit any of these topics or explore the Sim Racing League framework in general or explore the Autodrive ecosystem as a whole. We would like to thank everyone present here for your kind attention, and we now open the floor for any question and answers. So you can post your questions either in chat or directly, unmute yourself and ask the questions directly.
Hello, Chinmay and Tamay. Thanks for organizing the orientation and briefing the good the contents today. Yeah, if you remember, maybe 6-7 days ago, I added many questions regarding the frequency of the roast to the topics. Yeah, I was waiting for the conclusion of the issues I was facing. But it seems there was some update, like introducing headless mode and recommending the distributed environment. Was there some significant the frequency improvement in this new introduced environment?
Yes, that's a good question, and thanks for back communication. So after you had posted some of the updates, and after the kind of debugging steps that we uh, talked or walked you through, what we decided was that since these issues would be more common in different compute settings, that's the reason why we were working most of the time in the past few days to release these two new updates. One is the distributed computing mode, which was already present, but more importantly, the headless mode, which was already present but didn't offer you to set your arguments via command line. So that's a good question. And the answer to your question is yes, we have seen significant frame rate improvements. And by frame rate, I don't mean just the simulator frame rate, but more importantly, the topic rate on the API side. Uh, because we have tested it on a few different machines, I can say that the headless mode typically, as I was already explaining, would be limited by your CPU limitations. Since we are disabling the rendering, any bottlenecks with respect to the rendering pipeline, the GPUs or the display drivers would not have any effect. So if you are running on a good enough CPU, you should have consistent rates for the topics. But if you are more interested in running things with cameras, for example, we have also tested the distributed computing mode, and what we observed is really high throughput when things were run in a distributed computing setting, and that was with Wi-Fi. So probably I'm assuming with Ethernet or other means of wired communication, you would have even better performance and frame rates. And that's typically because you are running one entire workload of simulation, for example, on a dedicated PC, which is not running anything else in the background, and you're running your dev kit on the other one, where again, as I said, this can be much lower grade than what you're using for the simulator. You can even use your embedded compute boards such as the Jetson, Xavier NX, or others that are actually physically present on the F110 vehicles. Although we won't recommend doing that, you can certainly use them. But more importantly, coming back to the CPU portion, now since the operating system only has one task to handle, it kind of course, there are other tasks running in the background for any OS. You will still have inconsistencies, and typically we have observed it with Windows operating system. The scheduler for Windows is quite fragile, and it will affect your simulator performance in terms of the frame rate, for example, that you are getting out of the simulator at each instant. It may fluctuate a little bit because the scheduler at sometimes wants to prioritize other tasks that are running in the background. But Linux is far more robust to this, and you should be pretty much expecting fixed frame rate. It can be throttled based on limitations of your GPU and graphics pipeline, but it should be much more stable on a Linux operating system than on Windows. And yeah, because you're running things in distributed now, I remember you had also mentioned that your specs, the compute you are using for running this competition framework on your side are much better than what we are proposing in our documentation. So if you use the simulator on just the simulator on that, and then establish a communication channel with some other low-end PC that can be your laptop or even the Jetson boards, to run the dev kit, that should be pretty much real time, and you should be getting consistent topic rates now.
Yeah, I just tested the headless mode in my PC, and I've got just one the hertz improvement compared to the simulator mode, but still I am not getting the 20 hertz for the LiDAR. It's a 11 hertz and so on. So yeah, it would be appreciated if you can share us the switch to the demonstration the mode, and show us the FPS in the simulator side, and then the roast to topic, the hertz, the rate in the terminal. If you can quickly show us, I just wonder. And maybe you can show us the settings in the Ubuntu on that the demonstration mode, the PC. You can click to the display in the Ubuntu setting, then maybe it shows the monitor frequency rate. In my case, it's a 60 hertz, so the simulator GUI, the program doesn't go up to the 60 hertz. I just wonder, your demonstration environment have a more than 60 hertz, the monitor frequency, and if it is really the reason, the limiting um, the
Sure.
protocol frequency rate.
Yeah. So stop sharing. So one of the things that you want to note right now is that we are not using the same spec PC that we have
Okay.
defined in the technical guide. That's
Mhm.
because we are in a conference room right now and using our laptops. So just to note, and Chinmay is, as I'm speaking, Chinmay is basically pulling up the demo for you to basically show how things work on our side. While that's happening, if there are any other questions, feel free to ask or post in the chat. But we may have to cut you short if, like, once Chinmay is done setting things up. So as you can see, the frame rate is currently throttled at 60 Hertz, even on our side because of the display.
Okay, maybe yeah, similar environment with my environment. Yeah, instead of the echo, maybe just type hjet, then it shows the rate. Oh, it gets 16.
Yeah.
Mm-hmm.
So yeah, we are on our laptop getting 16 hertz with both the simulator and the dev kit running simultaneously.
Mm-hmm.
But
Yeah, it
with
seems to be faster than my environment. I'm getting 11 hertz, 12 hertz. In the headless mode, I get 12 hertz. So
I
yeah, but
think,
still
yeah,
the LiDAR according to my yeah, I'm also the newbie in the F1 10th. I live in Abu Dhabi, so this is first time I participate the F1 10th, and I had no time to get that level of the knowledge for the attending this challenge. So, but as per my understanding, the LiDAR, the hertz, the frequency rate is 40 hertz per
right,
second, and the minimum requirement for the real LiDAR device for the F1 10's real the physical racing is a 20 hertz. But if you are getting the 16 in the most of people's environment, then yeah, in my case, I'm getting just the 11, 12 hertz in the maximum. I don't know. The last week, I just received the 8 hertz, 9 hertz in the best condition. Now I see 11 and 12 in the head list, so definitely there is some improvement, but still it's under 20 hertz, which F1 10's physical racing is recommending as the least requirement. So, and also I shared the my video that it shows the hertz keep going down after 5 minutes. After 10 minutes, it goes down to 4 hertz, 3 hertz. So
oh, okay,
yeah, my plan was, doing some reimbursement learning. Then that was my plan so far. It's a basic plan, but because the LiDAR sensor frequency rate is keep going down, I still I couldn't do the cycle of the reinforcement learning, successful learning because of this kind of the issue, the frequency rate down, the the learning is not constant.
I
So
see.
yeah, I try definitely the distributed environment, but yeah, I'm not sure if I can achieve the at least 20 hertz constantly in my environment. One thing I give you the opinion, or yeah, this is opinion, because from my experience, the when I launch the game in my the Linux environment, I see 200 FPS displayed.
Okay,
Even though my monitor is a 60 hertz, the game itself shows the 200 hertz. But some game or the Unity-based program limits to the monitor capability, right? So it is kind of the optimization. It doesn't go over the 60 hertz, which is the monitor, the frequency. But some game doesn't optimize like that. It does the 200 FPS, even though the actual the frequency due to the physical hardware limitations, so 60 hertz, but the simulator uh, game or the simulator, yeah, might
right.
do this kind of optimization. So
Yeah,
maybe
sorry.
Did you have something more to say?
Sorry?
Were you done or did I cut you? Did you have something more to say?
Oh, no. But you got my point.
Yes,
The
yes.
the
So
current Unity-based simulator seems to have kind of some optimization that, the making the FPS rate to the exactly the monitor the frequency. If you don't do this kind of optimization by some option in the Unity side configuration, source code settings, I don't know, but maybe I can see the more FPS, then as you recommended, to try the more the rendering the option, the ultra mode, it will probably show more than 60 FPS in my PC case. Then maybe I will get 20 hertz for the LiDAR frequency, but at the moment, the simulator based on the Unity seems to have the optimization that makes same FPS and then the monitor the frequency.
yes. So first of all, the simulation that is happening at the backend, that is the sensor physics as well as the dynamics for the vehicle as well as the environment, that is being calculated at a fixed time step of one millisecond. So that's 0.001 seconds. And
Mhm,
that is very deterministic in the sense that that time step is not compromised depending on whatever compute requirement or computational resources you have.
mhm,
Frame rate here is only specific for the visual rendering. And one thing that we have observed for, especially as you were mentioning, some other vision-based applications such as other games or potentially other simulators, the
mhm,
frame rate and the physics time step are interlinked and correlated. But in our case, we have kind of segregated that so
mhm,
that it does not affect each other. So that is one thing. And the second thing, as I mentioned, the simulation itself is happening. For example, if you consider the LiDAR, it is happening at the real frequency of the sensor. It's just the fact that you are not able to pull the messages at the same rate because of the issues in terms of the hardware or software configuration of your compute platform. So you don't have to worry about the effects that it's going to cause in the simulation because those are still going to be the exact same. The only problem is that you are in particular not able to get the or achieve the same information on the
mhm.
same rate
Yeah.
of information on the ROS2 topics. So for that, we would highly recommend that you particularly use both the options in this case. If I'm assuming that you are not using camera-based uh,
No.
autonomy algorithm, so you can try to use headless mode in a distributed computing setting
Mhm.
potentially, so that these kinds of bottlenecks are not causing any issues for your application.
Actually, I tried distributed environment with the MacBook Pro as a simulator environment. So the native Mac simulator and connected with my Linux PC over the wired the LAN connection. But it was last week. I got just 3 hertz for the LiDAR sensor. I don't know, but yeah, the FPS in the MacBook environment is more than 60 FPS. So without connection, without the bridge connection, it was shown as 120 at the FPS. After the connection, then it goes down to the 80 FPS. But somehow LiDAR frequency was just the 3-4 hertz on the wired LAN connection. I don't have Windows machine, so
No,
uh,
Windows is anyway the last OS that we would recommend anyone using because, as I said,
mhm,
Windows is not very stable in terms of scheduling the tasks.
mhm,
So the ideal OS that we recommend everyone is the Linux OS. That's because we have in our lab access to Linux-based machines, and that's where most of the testing has been carried out. Although our laptops do use Windows and we have tested things on Windows, Mac OS is something that is least tested from our side. That's because we have to typically go to a friend to lend his MacBook and then use it to test our algorithms. So that's done only a few times as opposed to Linux, which is done most of the times, followed by Windows.
I see. In my case, maybe the headless environment is the best that I can try. I was blocked for this trouble for 6, 7 days. I only have 1 week. I'm not sure if I can attend the qualification, but I will try my best. All right,
Sorry to
that's
hear
it
that.
from my side.
Yeah, sorry to hear that. Again, as we mentioned, try both distributed and headless mode. And I think in the Slack you did mention that you have a 4090 GPU, which I'm assuming is not in a MacBook. So whichever PC that you have the best configuration, try running the simulator on that, and then the dev kit can be run on any other compute that you have. So just a suggestion.
Thank you. Thank you.
Another thing for the next week's qualification round is that you do not necessarily have to be as fast as possible. You can try to complete 10 laps autonomously, and that's very sufficient. Like, as long as you can even take 2 hours to complete those 10 laps, you can really drive at 0.01 meters per second. It's not an issue as long as you complete 10 laps without more than 5 collisions. So if that's something that's bothering you in terms of qualifying, you will automatically qualify as soon as you complete 10 laps, no matter how much time you put on the lap.
All right.
Okay, do we have any more questions? I think most of the participants have left, so if there are more questions, we can wait a few more minutes. We are already over time, so we do understand and value your time as well. So if there are no more questions, maybe we'll wait for another minute and then we can. Okay, there was a chat question posted in the chat. I have a question about ROS to frame. So what is exactly your question about ROS to frame? Okay, you want to use SLAM and particle filter. But it is hard to use the map frame. But on headless mode. Okay, but it is hard to use the map frame. It's already use it on headless mode. I'm not 100% sure that I understand your question, but what it seems to me is that you already have a map frame before building the map, and that is where you are facing issues. If that's the case, then I think you're using probably a very old version of the competition framework where we had called the world frame a map frame. But in the like starting from the second update itself, and it should be consistent thereafter, the racetrack is now called a world frame instead of the map frame. And that's because we after releasing the first iteration of the framework, we realized that this conflict might be an issue for some of you who are using map frames for slam maps. So the frame right now with the latest version and with a few earlier versions as well should be called world, and there should be no map frame from the baseline dev kit container that we have provided. There should not be any map frame present in it. So does that clarify your question? Chinmay is just showing the screen share. So right now, this world frame that you see, that was earlier in the very first iteration called as the map frame, but we changed it to the name world very soon. And so that after that, it has been consistently called the world frame. So if you're seeing a map frame, that probably means that you're using a very older version of the uh, competition framework, and we would really recommend you to update to the latest version. Did that answer the question, or was your question something else? Oh, okay. Thanks. So thank you again for attending today. If of course, if you have any questions from now till the qualification, you can definitely post them on the Slack channel. Uh, or if there are anything from our side that we may want to announce, we will announce them on the Slack channel as well as on the competition website. So hopefully the communication barrier should not be an issue between any teams and the organizers. So thanks again for joining and have a wonderful day. Good night, based on the time zone you are in. Bye bye.
Thank you. Bye bye.